Hello everyone, and today we are going to discuss IOQM 2025 2 and 3 marks from the topic Algebra. And here is the first question. Before trying this question out, please pause this video and try it out by yourself. If you have tried it already, then try to see if you can understand my approach. First question says the sum of two real numbers is a positive integer n and the sum of their squares is n plus 1012. Find the maximum possible value of n. So they are saying the sum of two real numbers is positive integer n. So let's say x plus y is your n, and they are saying that sum of their squares is n plus 1012. That means x square plus y square equals 1000 n plus 1012. 1012, and they are asking you to find out maximum possible value of n. Now if you see, there is an addition over here also there is an addition, and clearly it is visible that the RHS has to be maximized. So one thing is visible, that if we keep x equal to y equal to n by 2, then automatically n will get maximized. So if we keep x equal to y equal to n by 2, this also can be proved by calculus. If you are someone preparing for JE, then using calculus also you can prove that x equal to y equal to n by 2. Now if we substitute it in this equation, then we will come to know that it is going to be n square by n by 2 whole square, and then you will get a 2 times because x is equal to y, and this should be equal to n plus 1012, and if we simplify this you will get n square by 2, because here you will get n square by 4 and 2 by 4 is 1 by 2. N square by 2 is equal to n plus 1012. Then if you take LCM, you will get that n square is equal to 2n plus 2024. Okay, because here you will get 2, here also you will get 2, and if we keep 2n in left hand side, then we will get n square minus 2n is equal to 2024. If I try to complete the square, then you will get n minus 1 whole square is equal to 2025, and if we take root on both sides, which is square root, then we will get n minus 1 is equal to root of 2025, and if you are familiar with the root of 2025, it is 45. Here you are not going to take minus 45 because n has to be a positive integer, so that's why if minus should not be considered, hence n should be 46. So the final answer for this question is n is equal to 46. So let us move on to the next question. So here is the next question. A function f is defined on the set of integers such that for any two integers m and n, f of mn plus 1 equals f of n minus f of n minus m plus 2 wholes, and f of 0 is equal to 1. Determine the largest positive integer n, capital N, such that summation of f of k from 1 to n is less than 100. Okay, now whenever you have this kind of equation given, almost always we have to substitute m as 1 0 or n as 1 something like that, and after that we should be able to get f of something is equal to the same thing plus other terms. So let us see how we can do. If I keep m as 0, which implies f of 1, because m into n will be 0, 0 into n, so you'll get f of 1 is equal to f of 0, because m is 0, so f of 0, and you will get f of n, and then you will get one more f of n with a minus f of n, and then you will get a minus m, which is 0, and finally get plus 2, and f of 0 is 1, so you can cancel out this f of n and minus f of n. Then you are finally left with f of n as 2, so we will get f of 1 as 2. Alright, f of 1 as, after m equal to 0, if we take n as equal to 0, then what will happen? F of 1 is equal to f of m, f of m, f of n equal to f of 0 is 1, and here you will get minus f of 0, which is 1, minus m plus 2, and f of 1 is actually 2 if you see here, so 2 is equal to f of m minus 1 minus m plus 2, and we can cancel 2 on both sides, so 2 is cancelled, and finally you will get f of m is equal to m plus 1. So finally you will get the equation of f as f of m is equal to m plus 1. So the question is saying that to sum this f of k from 1 to capital N. So if I sum this from 1 to capital N, and if I take f of k, then we'll get it as summation of 1 to capital N m plus summation 1 to capital N 1, and summation of small m will be m in capital N into capital N plus 1 by 2, because this is sum of first n natural numbers, and if you sum this you will get a capital N, and if you take n as common and take it LCM with 2, then you will get n into n plus 3 by 2. So this is your f of k from 1 to n summation. Now if we take this n into n plus 3 by 2 and take it with inequality as less than 100, then you will get something like n into n plus 3 by 2 less than 100. Then if we place these 2 over the RHS, then we will get it as n into n plus 3 is less than 200, and if I multiply this, then we'll get n square plus 3n, and if I complete the whole square, you'll get it as 9 by 4, and this should be less than 200 plus 9 by 4, and if I write in terms of whole square, we will get it as n plus 3 by 2 whole square, and this should be less than 809 by 4. Okay, 809 by 4, and if I take root on both sides, which is the square root on both sides, then we will get it as n plus 3 by 2, this should be less than 809 root by 2, and if we take 3 by 2 in RHS, then we'll get n is less than 809 root minus 3 by 2. Now if you see, root of 809 is actually greater than 28, okay, greater than 28 but less than 29. Okay, if we take root of 809, this is actually greater than 28 but less than 29, because 28 square should be 784, right? Because 28 into 28 is 64, 6 and 22 then 56 as 784, and 29 square should be 841, and clearly 809 is between these two numbers, so that's why 809 is between 28 and 29. So this is quite clear that n is also less than, n should be less than 28 minus 3 by 2, but the problem is that if we subtract 28 and minus 3, you will get 25, and 25 is not a multiple of 2, so here you will not get an integer at all because they are asking positive integer. So that's why we have to take the value of n as 27 minus 3 by 2, and if we calculate, you'll get this as 12. So n equal to 12 is the final answer for this question. So let us move on to the next question. So here is the next question. This question says that let f of x and g of x be two polynomials of degree 2 such that f of minus 2 by g of minus 2 equals f of 3 by g of 3 equals 4, and they have given specific values. Here is the first thing, and they are saying degree 2, they are saying g of 5 is 2, and f of 7 is 12, and g of 7 is minus 6. They are asking you to find out value of f of 5. Now if you see, they have given two ratios and equated to 4. So if we consider h of x as f of x minus g of x, f of x minus 4 times g of x, then it is quite clear that roots of h of x are minus 2 and 3, because if you cross multiply the denominator into the RHS respectively, and if you bring that RHS to the LHS, then you will get 0. So this implies that h of x roots are minus 2 and 3. So we can also write h of x as lambda times x plus 2 and x minus 3. Why we are writing lambda? Because we are not sure what constant will sit here, because if we place minus 2 or 3, anyway we will get 0, so we are not sure which is constant. So to solve this lambda, we have to substitute x as 7, because both values are given, f of 7 12 and g of 7 minus 6. So if I take this equation h of x and equate with this first one, then you will get something like f of x minus 4 times g of x is equal to lambda times x plus 2 and x minus 3, and if we substitute x as 7, we will see that f of 7 is 12 and g of 7 is minus 6. So f of 7 is 12 minus 4 times of minus 6 is equal to lambda times of 9 and into 4. So this is going to give you 36, 12 plus 24, and this should be equal to lambda times 36. This implies lambda should be equal to 1. So finally the equation that we'll get is f of x minus 4 times g of x is equal to x plus 2, because lambda is 1, and x minus 3. And if you substitute x as 5, you'll get f of 5 is equal to 4 times g of 5. G of 5 is 2, and 4 into 2 is 8. Okay, so 4 into 2 is 8, plus 2 into 2 is 4. Sorry, 5 into 5 plus 2 is 7, and 5 minus 3 is 2, and 7 into 2 is 14, and 88 plus 14 is 22. So the answer for this question is f of 5. F of 5 should be equal to 22. So that's it for today's video, and hope we'll meet you soon. Thank you.